Our next type of problem, we're going to find the heat of reaction for the formation of magnesium carbonate. I'm going to show you the reaction, even though I am confident you could get it yourself. And then we'll need 3/2 O2. So if I was going to do delta H reaction equals products minus reactants, magnesium carbonate has a heat of formation of negative 1113. Over here, we're dealing with pure elements. So those guys are all going to have values of 0. So it is no coincidence that the heat of the reaction also equals the heat of formation, or the value that should be in the table or is in the table for MgCO3. So in this case, writing the reaction is slightly unnecessary to getting the heat of the reaction. So for example, let's say I give you this question. Find the heat absorbed or released when, excuse me, all right, how about 10 grams MgO form? Just like every other heat problem, I can write my reaction, and I know my heat of reaction is going to be the same as magnesium oxide. Its value on this table. So negative 601.8, because each of those have a value of 0. Now, 601.8 kilojoules are released when 1 mole of MgO forms. Why 1? Because that coefficient of 1 there lines up with that. Whoops, scratch that. It's that coefficient of 1 that lines up with there. I want to know how much heat is released when we only have 10 grams of magnesium oxide. Magnesium oxide has a molecular weight of 40. So 10 divided by 40 is 0.25 moles. And I can put the 0.25 here. Now cross multiplying to solve for X, or 601.8 divided by 4 gives me 150.5 kilojoules released as my answer. You should be good now for the heat of formation problems in the homework.